First things first, and you're welcome to start your presentation. Good luck, Sebastian.
Thank you very much. So again, welcome to my talk. So I hope most of you know what Docker is, but I will give a brief introduction. So the title is 7 Years of Docker, the Good, the Bad, and Python Packaging. So you will learn something about how Python interacts with Docker. So first of all, something about me. So I work for a company which is called Blue Yonder. The history is quite complicated. So there was a company founded in Germany, in Karlsruhe, let's say roughly over 10 years ago, which was bought by JDA, but then renamed to Blue Yonder again. So I'm working at the original Blue Yonder and at the new Blue Yonder. So we are building data-driven SaaS solutions for the retail industry, or everything around supply chain management and supporting systems for supply chain. So something like automated replenishment or automated pricing. And I'm doing what is now called data science since over 10 years now. Back then when I started, the term data science wasn't even invented. So I'm working at Blue Yonder since nearly 9 years now, so it's quite a while, and currently working in the platform team. We are providing the platform for all these sophisticated calculations of optimization algorithms and so on. But now I also in a role of an evangelist, so I need to go out and tell about all the fancy stuff. But lucky you will hear nothing about what we are doing at Blue Yonder. It's solely about Python and Docker. So it is a little known fact that actually in a PyCon, so it's something similar like this conference, so a conference about Python in the US in Santa Clara in 2013, so 7 years ago, there was a lightning talk. I don't know if you know what lightning talks are, but these are, let's say, not scheduled talks, but you just go there and tell 5 minutes about a topic you are interested in. So a very tiny thing, and there Solomon Hykes went to stage and he presented something he called Docker. So this was the birth date of Docker. And yeah, it was quite a remarkable live demo. So he showed something which wasn't really there before, and everyone was like, wow, that's crazy. But in the beginning, it is not really something specific for Python. I mean, you can Python use inside Docker, but not specifically for Docker. So it's kind of remarkable that it was a PyCon where it was presented and not some Java conference or whatever. But I think this is quite remarkable. So I'm interested in, is the relationship between Python and Docker still, let's say, like on the first day? And this is what we see during the talk. I mean, it was remarkable, but also it wasn't that perfect. So Solomon made a small live demo, and he had a typo, and the typo went on and on and on and on and on and on. But I mean, it was funny. So you see, there is sometimes something can be funny. I think it should go into a museum, because I think it's one of the very important typos in the world, because Docker more or less transformed the whole industry, right? So it's all the containers, and what we just heard in the talk before, everything you hear around Kubernetes and so on is only possible due to this remarkable 5 minutes keynote. So if you don't take anything with you from the talk, maybe just take this one, a small anecdote. It's always good. So, but I mean, not everyone is familiar what Docker is. Some people use Docker but still don't know what it really is. So I, for the sake of understanding some of the things which might go wrong, it's important to understand what Docker really is. So there are, I mean, most of you know that there are virtual machines. A virtual machine is a simulated computer inside a computer. So you have your laptop, but then you can start a virtual machine, and the virtual machine really simulates or emulates a whole computer. So it simulates a hard disk, it simulates memory, it simulates all of the drivers and so on. Now, Docker is somehow like a virtual machine, but it uses some kind of a trick. So Docker is not a virtual machine in that sense. It is something specific for Linux. So Linux has the ability. So if you know what Linux is, it is mostly just files on your hard drive. So everything is organized in files. So even if you plug in your headset, it pops up as a file in some subdirectory of a tree. So once you copy a whole subtree of all the files, you more or less can copy the whole operating system. And this is more or less the foundating feature which is used for containerization. So as you see here, you see bin, user, var, home, and so on. And then you see a subtree in a subfolder called change root. So this means now you have an operating system running in the operating system, but it shares the whole hardware. So there is no real difference. It's just using another sub-file system for all the things like configuration and so on, and which programs and so on. So this is like an isolated environment. It's a confined environment. And this is the heart of Docker. So Docker is really just, you can make a zip file and just package all these files together, move it to a different computer, and then start it there again with these commands like cgroup, namespaces, change root, and so on. I mean, you won't understand everything in detail, but what you need to understand that somehow this is a specific thing for Linux. So on Windows or Mac, this does not work like this. So if you want to make it in one picture, Docker is something like this. So you have this spine in the middle, and this is what is called the Linux kernel. So this is really the thing running and operating all your devices, all your memory, your CPU. But then you can put different kind of these containers on top of the same Linux kernel, but they all share the same Linux kernel. So it's just a bunch of files using the same kernel. Now, having said this, the story is a little bit more complicated, right? Because most of us don't have a Linux laptop or a Linux desktop PC. I mean, some have, and lucky them. But I mean, for example, I have a Mac, or some have Windows, and of course, we don't have a Linux kernel there. So if we want to use Docker on a Mac or on a Windows, there is a problem, because on Mac or on Windows, Docker actually is a virtual machine. Because if you want to run Docker, you need the Linux kernel. So what is done on Windows and on Mac, at least formally, I mean, in Windows there is something really exciting happening with the Windows Linux subsystem, but I won't go into detail for this one. So there will be a virtual machine started, so it completely emulates a complete computer with everything, with hard drive and so on, running a Linux, and then on top of the Linux, there will be this Docker environment. And I can already leak something here. So whenever you have problems running Docker on Windows or on Linux, most of the time, what in my experience and also on others, the bottleneck is the mounted file system. And what does this mean? So you have your host, which is your laptop, and there you have files, of course, for example, your source code. Now you start this virtual machine, and inside the virtual machine you start Docker, but you want, for example, execute your code inside the Docker container. So somehow the files need to go into the Docker container. So what is happening? You mount your host file system into the virtual machine, and then mount the files into the Docker container. So there is a two-step thing even for accessing the files. And of course, I mean, this always takes some working to transfer it somehow. So there are completely different technologies depending on what you're using. But in my experience, most of the time, this is the actual problem. So some tips here for the start. So this is mostly for Mac now. So if you have a Windows laptop, of course, things might be different, but some things are in general the same. So what I already said is the bottleneck often is the file system. So please don't mount all of your files which you have in your complete user folder into the VM where Docker is running, but only, for example, your folder with your source code. This immediately reduces quite a lot of the back and forth for the files. Then also use as little volumes as possible. And only mount what is needed in the containers. Then this is let's say a bit of an expert trick, but you can try to play around if it is slow. So this really depends on your machine and so on. So there are different guarantees for your volumes. You can think of, if you change something on a file on your host system, how fast is the change transferred into the virtual machine and then into Docker, and the other way around. So if you change something in the Docker, how fast is the change also on the host system? And of course, if you reduce some guarantees there, like it is okay if it's only a second after on the host file system, then of course things can get much faster inside. So there are these two options, delegated and cached. I mean, this is really something. Once the slides are there, you can have a look. If you have these kinds of problems, you can play around with this one. Also, there are completely different ideas than mounting. So mounting is something special. So you really mount the file system in there. But of course, you can also just copy files there. So you can use things like rsync, or there are many tools you can do things like this. So there you would really take the file and copy it into the Docker container and vice versa. This might speed up execution in the Docker container. You have to try it out. I mean, there is no one solution for all. Okay, so these were some tips which is really general about Docker if you use Docker for local development. But now, I mean, this is the Think Python track. So now let's put the snake into a container and really see, have a look at the specific things of Python in Docker containers. So the first thing, at least you need to decide on, is what about virtual environments? So if you know Python, I guess you are all familiar with virtual environments, or let's say with conda environments. That's more or less the same. So now, why use virtual environments if you're working on your host, let's say your laptop? I mean, that's easy. You might work on some project on the weekend just for pure fun, and this uses, let's say, Python 3.6. But for work, you need to work on a Python 3.8 project. So you somehow need different environments for different versions of Python or different dependencies, like, I don't know, NumPy or whatever. So you need a way to have separate dependencies, and this is done via virtual environments. So, but if you use Docker, I mean Docker, then you can have arbitrary many of these Docker operating systems. So you can think of, okay, so why should I use a virtual environment? Because, I mean, Docker already is an isolated new operating system. So taking the same example, you can have one Docker container for your weekend project using Python 3.6 and another Docker container using Python 3.8 for work. So in principle, this is correct. So you now have another layer of virtual environment, but still I would recommend to at least think about doing this one, because once again, we are using a proper Linux kernel. So for example, a Debian or something for your Docker. And the Debian also has a Python version. For example, it might be a Python 3.6. So now imagine you change the default Python version. There might be some weird issues going on with your host, with your Docker operating system. So I would recommend to at least think about still using virtual environment inside a virtual Docker environment. But yeah, I mean, this is also something you need to figure out. I just want to make you aware that it is not, I mean, it is not a at least not a bad thing to do it, right? I mean, then you are safe, you're completely isolating from all the system Python packages and so on. Yeah, so that's it. So otherwise, I mean, I at least had already strange things happening. So I always do it. The first thing is I start a Docker container, and inside the Docker container, create a conda or a virtual environment and do all the things in there. So then I'm just safe, and I never have to think about if I do mess up something with the system operating system. Of course, I already mentioned it. So conda is an interesting alternative. I don't know if you know conda. Conda is more or less language agnostic. So it is a Python. It is a package manager plus a distribution plus some environment manager. So you can have something like a virtual env, but for example, you can also have different Python versions in there, and it really ships binaries. So you don't have to compile things for your operating system. And it also keeps track of non-Python dependencies. So for example, if you are heavily using data science stuff, so you have all these very ancient libblast libraries, C libraries from the 70s, you really don't want to recompile them specifically for your operating system. So something like conda would just use it and precompile binaries and put it there. But it feels even more crazy because now you ship binaries into a Docker container. So it is like a layer on top of a layer on top of a layer. But I have to admit, it just works. I never had problem with using conda inside Docker containers. But yeah, that's something to consider. Now, again, I already said to you, so the bottleneck is always the mounted file system. Now, if you look into a virtual environment, what is happening there, it's actually thousands of files which get created and put somewhere. So even installing something in a subdirectory, which is mount our source code inside the container, this file just vanishes. So you have a broken setup all of a sudden. So by just starting a Docker container, you have a broken setup. We can do it the other way around and just install it after we mounted the host file system. This works, but then every time we source a new, we create a new Docker container, we have to reinstall the whole thing, right? And I mean, all of a sudden on your host file system, there will be a new directory called egg.info. And I mean, this is mostly just an aesthetic problem, but still there is a new directory and you don't know where it is coming from and so on. There is a thing called Python setup develop. Probably you used that before. It is more or less the same like pip install editable, but you can change more or less via a hack, or accidentally, you can change the position of this egg.info. But then we have to fiddle around with the Python path. So I found this one in a blog post. So someone said, we can use the old Python setup develop to more or less work around this problem of this directory inside the root of our source directory, which we mount into the Docker container.
Hello?
And I just marked this here. So he writes then, so it turns out it works perfectly. The only catch being we need to update the Python path to deal with our fuckery.
Excuse me?
I mean, this is just to show you, yes,
Sebastian,
Docker is awesome, Python is awesome, it works together, but there are still some corners which are really not that polished as it could be. So yes, I mean, we could call it fuckery, but these are the things, and they are still there. So they are still not solved after all the years and all of the long discussions. So another problem, which admittedly was more dramatic in Python 2, and of course nobody uses Python 2 anymore. So I think it is still there, but I have to admit I wasn't able to really reproduce it by now. But I still think you can get the same thing. So if you are using Docker heavily and maybe using different Docker containers for different things, then it might be that you already saw this strange exception. It's called,
Sebastian?
yeah.
Hello? Excuse me,
Yeah.
we've got some technical troubles. We can't adequately demonstrate your screen and your presentation for some slides. I think, is it possible for us to turn off our stream and restart it from some specific place in your presentation? I think about several minutes.
Okay, so I just go back. Okay, I have to restart the stream.
I think we should start. We should restart, or we can replace it.
Should I restart or will you restart?
You just will restart, or you just will start your presentation from slide with virtual env plus Docker. And as I got information, it looks like we're better now. Our stream is cured. Can you restart it from this slide?
From this slide?
Yeah, excuse me.
It's half of the talk, right?
Excuse me, we've got a really bad connection. Sorry.
Okay. Okay, so then let's go back quite a bit. Okay, I have to find a way into the talk again. Okay, yeah. So okay, so there's another option. You can also create the virtual env already during the Docker build. So maybe I explain a little bit what a Docker build is. So for using containers, we are using images, which I explained already is just a bunch of files. And to create this file system, there is a build step. So we have different commands which are executed, like apt-get install some packages or pip install some packages and so on. So you can create a virtual environment and install all your requirements already during build time. But of course, there's also a drawback of this one. So the drawback is if you need to change something, for example, a dependency, you would need to recreate your whole Docker container, which might take a while. So it is a trade-off. So it might speed up some things. For example, if you don't need to change anything in your dependencies, then this might be the best option. If you need to change often some of the dependencies, like going version up or trying out new things, then this might be actually slower. There is another pro tip here. So if you know a little bit about how Docker build is working, the Docker build will execute all these commands in your Docker file. And each command will create a new layer, which is more or less a new snapshot, but it will cache all these different layers. So once it knows, okay, I already executed this same command and it hasn't changed anything, it will just use this layer when it was created already before. So a trick here is if you need to change things often, like changing things in your requirements file, dependencies, then just put this at the end, because then Docker will go through your Docker file and just say, okay, this is cached already, cached already, cached already, cached already. And only at the last step where you install your requirements, it says, okay, now this is something new, so I need to redo this command. But if you're lucky, then it's just the last command which needs to be executed, and all the other things are done already. Now there is another thing we need to consider, and this is Docker Compose versus Docker. So if you heard about Docker Compose already, I nonetheless will briefly explain you what it is. So for example, if you're developing a web server, this web server might talk to a database. So you have two services, a running database and a running web server. Now in Docker, the idea is that you only have one service per container. So this would be 2 containers, one for the database and one for the web server. And this is not trivial to orchestrate. So there is a tool called Docker Compose, which will orchestrate all these different services together. So it will take care of the networks and so on. Now you can think of if you want to develop, for example, your web server and or some other stuff locally on your laptop, you say, I don't need many services, it's only one service. So you can think of saying, okay, I only need Docker, and I don't need Docker Compose as I don't have many services. But here's my recommendation. So I always use Docker Compose more or less because it has a huge advantage. Docker Compose composes all these services using a declarative YAML file. And even if you only have one service, still what is in Docker, all these different command line options, like which volumes to mount, which networks to use, which environmental variables to use, and so on. So this will all be in command line options. But if you use Docker Compose, also if it's just one service, it's all in one file. And this file you can check into your version control system and share it with your colleagues. And that's a huge advantage. So you don't have to type anything. You just put it in a file and you check it into your source code. So it's also versioned. So everything of your configuration, also if it's just one service, is versioned. And so my recommendation is just always use Docker Compose. And there is a fun fact. So there was a project called Fig back then. Now it is part of the official Docker, and now it is called Docker Compose. And Fig was originally and still is a pure Python project. So if you touch Docker Compose, it is everything in Python and just uses the API to talk to the Docker daemon. So it's quite neat. You can have a look at the source code. I mean, there you see where all these containers get orchestrated and so on. So it's quite fun to also have a look there. Now there is another problem. If we want to do local development, then I mean the natural thing is you change something in your IDE or in your editor, you change a line in your code, and you want to execute something, and this change should be reflected immediately when you execute it. So somehow to execute things, we need to install so that Python can find out where are all the modules and so on. So, I mean, we could just package everything up and install it like we would do it afterwards, but then we would need to reinstall it after each change we do in our IDE. So this is where a thing comes in, and I guess you already used something like this. So there is pip install minus editable, or -e, it's the short form. So it will just install the package, but not install it somewhere else in your virtual environment, but just make a link in your virtual environment to your source code folder where you are just editing. So everything you edit will immediately be reflected in each execution. So you don't have to do any reinstall or any build or whatever. So it's just there. So this is something we need when we develop something in Python. And there is a problem, at least in the whole Python ecosystem, around all these things like wheels, packaging, and so on. So this is also why I called the talk The Good, the Bad, and Python Packaging. So for example, here you see a discussion on python.org about the specification of exactly such an editable install. And you see it's a huge discussion with many comments and so on. This one was closed at some point, but I mean, there is now another discussion going on. It's the third try on editable installs called the discussion. So you see, it's all but clear, and I guess, of course, I mean, it's not a trivial problem to solve. So at least it is not perfect. So again, we need this editable install for local development so that our source code is just installed. But there is a problem. So in the current pip editable specification, so what is currently there, it always creates a directory called my package, so your package name .eck info in the directory of the package root, so in your source code package directory. But now we said we want to mount the whole source code folder into a Docker container. Now there is a problem. So if we install the package with -- editable inside the Docker container, there are two possibilities happening, and both are not very good. So the first one is during build time, we install the package with -- editable, but then we start the container and mount the host file system into the container, which means as the file was created during build time, but the directory is not there on the host. Once we mount the directory into the host, we overwrite this newly created eck.info directory, so it vanishes, which means it is somehow a broken setup. So it does not work anymore. I mean, it will work, but it might have some strange bugs. We can also do it the other way around. So we first mount the host source code folder into the Docker container, then do the editable install, which will create a new directory. So all of a sudden on your host, you have a new file which is called eckinfo. I mean, this is more or less even the better frog to eat, because this is mostly just aesthetic problem, because now you wonder where does this folder comes from, and you need to know that this folder was created by the Docker container and not on your host. There is a third option. So some of you might know the Python setup py.develop, which is mostly the same. There's one difference. So let's say this is the ancient way to go. So pip is the recommended new way, which is more modern, has more features, but the setup py still works, and it has a huge advantage. It will put this folder wherever you execute this command from. So you can go into a directory which is not the root directory, which is not mounted from the host file system, execute this command from there, then this eckinfo file will be created somewhere else in the Docker container. So this is a trick mostly, and it's also not so nice because then you have to change different things, like for example the Python path. I found this one in a blog post, and I just wanted to show you what he writes about this thing. So he says, it turns out this works perfectly. The only catch being we need to update the Python path to deal with our fuckery. So this again tells you, okay, it's not at all perfect. It is somehow a fuckery we need to deal with. And I mean, this is state of the art. There is no way to do this any better than this one. So yeah. Then there is another thing with Python cache files. So probably, I don't know, probably you once stumbled upon such an exception when you want to execute a script or whatever, and all of a sudden you immediately get this exception. Admittedly, this was at least a bigger problem in Python 2, and no one uses Python 2 anymore. So I haven't figured how to provoke this one in Python 3. Maybe it's completely solved and just completely forget about the whole problem. But still, I want to at least mention it, because I think it is still a problem. So to explain it to you, what this is about. So I mean, you can Google for this, and then you find all the things, but I will show you the solution and what the problem actually is. So Python, if we execute Python code, it will pass the text file what we have written and translate it into Python bytecode files, which are called PYC files. I guess you already saw them somewhere. Sometimes they are also in subdirectories called pycache and so on. But at least these are the bytecode files which are then interpreted by the interpreter. And for some reason, somebody thought it is a very good idea to just put all these files next to the source files. So if you have a deep tree structure, then you will have next to each file, more or less, such files or such directories with some cached files. Now, the problem is, if we execute something in the Docker container, these bytecode files get created, but they are dependent on the operating system where they get created. Now, think of, and we mounted the file from the host file system. So what happens is, we execute code in the Docker container. These cached files get created, but they are also reflected on your host file system, so they are still there. Then you take another container. Let's say first you used it with a Debian system, but now you want to try it if it also runs on a Ubuntu. So you start a Ubuntu, mount again your source files into the Ubuntu container, and boom, all of a sudden you get this exception. What happened is the bytecode files do not work from different operating systems. At least you cannot guarantee that they will work. So Python saw, okay, I have already the cached bytecode files, so I don't need to recreate them, but they were actually from a wrong operating system. So that's really a bad problem. And a very bad problem is that it's sometimes a deeply nested source code tree. So if you need to do it by hand and manually go through all the files and delete them manually, it's a horror. So if you Google for this, you find this very, very nice solution. So I think it's one of the one of the ugliest workarounds which you can think of. But I mean, I now have it even as a shortcut in my bash, because I actually, at least for some times back, when as I said with Python 2 it was much more severe, I needed this very often. So this will just, I mean, this had nothing to do with Python, but this is a command which goes through all your subtrees and delete all files called either pycache or pyyc or pyo. So, okay, this is a nice trick. Once you stumble upon this thing, yeah, the only thing you can do is recursively delete all those files. Now, I'm mostly at the end of my talk, so I want to give one serious warning here. I showed you how to get at least some of the ugly corners of Python and Docker, using it for local development. And one thing I realized over time is Docker was built for a specific reason. It was to overcome the so-called snowflake problem. So what's the snowflake problem? So imagine you have your MacBook and your colleague has a Windows PC or whatever. So you program something, you send the code over, and he says, oh, it doesn't work on my machine, but you say it works on my machine. So this is a big problem, and for this, Docker was invented, right? We have this ability to just use this Docker container, transfer it to your colleague, and he starts the same container with the same files. Everything is completely the same. Now the problem is, with many things I showed you, you somehow will start to make a snowflake around Docker. So the Docker container itself might be portable, so you can move it around, but all the configurations or things you mount or do not mount and so on. So it starts again that you might, in your setup, you start the Docker container and everything is fine. Your colleague starts it and it says something like can't file ec.info. So what happened? I mean, maybe he did the mounting somehow differently than you are doing it. So this is just a warning. Always reflect, is it still, so how far do I go with a local development environment, which is really specific with kind of scripts which do things and so on, with aliases and so on. So just take this as a warning. And another, I mean, this is more, this is an outcry more or less. So what I showed you is, yes, we can put Python into Docker containers, and if you know GitHub, for example, the best way to try out a new program, a new service, a new thing, whatever, is always if they provide some kind of a Docker file and a README where it says just do Docker run X, and the thing you want to try out is running. So this is how we want to interact with new packages, new libraries, and so on. But what I showed you is, okay, there are some problems which cannot be really solved in a very, very nice fashion. You can do it, but it takes some time. So this is also just a warning. So please also work on the entrance to for example, if you open source something, then Docker might be the first thing users will have contact to. So please try hard to make it as seamless as possible, because I think in the end, all of our projects and open source contributions more or less should look like this. So it should be, yes, come here and start this Docker container with this very simple command, and everything is up and running in a very nice way. So yeah, it is not there yet. So there are some ugly corners, I have to admit, from Python side mostly, but also, for example, from the Docker side. But I think we all just have to work on it. We have to contribute. Maybe the discussions are long, but I think it's worth that we make it even longer and tell our opinion to something like this. So a very short outlook to the end. So how could we improve the situation? So this is at least what helped me a lot by reading blog posts and Googling for all these things. So I was under the impression when I first tried to properly set up a Python package in a Docker container, I was like, okay, I'm sure I'm stupid because I can't get this working. And then I found out, no, it's probably not me, because many others have similar problems, like the cached files and so on. So awareness is probably the first step. So this is the reason why I did this talk. So I said, no, I want to give a talk and just tell people it's probably not you. There are some dark corners. Not all of them can be solved, but yes. So also all of us should contribute that things are getting better. Also you, if you found some things like these, talk about them, write blog posts, do speak at conferences. This is a shout out. Then I think there is the Zen of Python, and there is a very important saying here. The Python way of doing it means there should be only one obvious way to do it, and this is clearly not the case using Python inside Docker containers. So we need to work on that. There should be just one way to do it, and this should be a very good way. Yeah. Okay. So of course, I mean, if you are able to write some scripts which might improve situation, just do it, put it out. So I did a very first start here, and I just tried to put everything inside let's say a tiny start. So how to dockerize Python scaffold into GitHub. So it's more or less just a tiny example. So these are the 1, 2, 3, 4, 5 things you need to think about and to make it right. It's all but perfect. So happy if you contribute there, but do the same, go out, talk about, improve the situation. And with this, I want to conclude with the very famous typo, hello world. Questions?
Thank you for your presentation, Sebastian. It was a really great and interesting presentation. Sorry for these connection troubles. I think due to this situation, we can't allow ourselves to ask questions in online format, in live format. I think they will be redirected to the chat. Is it okay for you?
It's okay. Yeah.
Thank you. Many thanks for your, and as I told earlier to our previous speaker, you will get our mascot of this conference and some special gift box to remember you about us, I think, one winter day.
Thank you very much for inviting me. Thank you for organizing such a conference. So very good. Thank you.
Thank you for your attendance.
Hopefully we see us next year. Maybe we see us also offline soon.
Hopefully we'll see you next time.